Welcome, trainees, to this explainer. Today, we're going to embark on a journey together as master and apprentices to uncover the unseen physical realities of our world. Now, you might be wondering, why is this so absolutely crucial? Well, because the world you walk through every single day is literally only a fraction of what actually exists. By learning to look beyond what your eyes naturally show you and really diving into the hidden mechanics of light, energy, and perception, you're going to gain the ability to perceive things that others can't even imagine. So, get ready, because we are about to shift your perspective entirely. Okay, let's dive straight into our secret syllabus for today. We'll be covering material versus immaterial light, shadows and object transparency, bending waves and illusions, balancing light and heat, the mechanics of camouflage, and finally, perceiving hidden conceptual energy. Section 1, Material versus Immaterial Light. Your very first lesson as apprentices requires understanding a pretty massive fundamental truth about our universe, and that is that light actually possesses a dualistic nature. It's not just this one simple thing that illuminates a dark room. To truly grasp this, we've got to clearly contrast the two sides of this coin. First up, we have material light. This is the aspect of light that has a very linear, highly ordered nature. It's the stuff that gives objects their physical form, defines their unique visible traits, and reveals the tangible, physical world that we interact with every day. But on the flip side, we have immaterial light. Now, this is an entirely different, completely invisible spectrum. It doesn't reveal physical boundaries at all. Instead, its abstract nature allows us, the observers, to perceive invisible realities and conceptual energy. Immaterial light doesn't just bounce off a surface, it actually responds directly to the mind perceiving it. It literally alters its manifestation based on your own nature as an observer. Today, though, we're going to start our focus firmly on the physical, the material light. And this brilliantly illustrates how material light actually works out there in our immediate environment. Material light flows in absolute, perfect straight lines, moving directly away from its source towards its ultimate destination. When it hits an object in its path, it reveals that object's physical form based on two really crucial factors: the specific spectra of light making contact and the object's transparency. I want you to think about this carefully for a second. The color an object ultimately assumes is based purely on the specific spectra of light that are reflected off its body. That reflected spectrum dictates its external color. But the internal traits? Well, those are dictated entirely by what passes through it. For instance, the air around us is completely transparent, which renders it totally invisible to our eyes. Water, on the other hand, while you can touch it and feel its weight, is mostly colorless because of exactly how penetrating light rays interact with its internal composition. Section 2, Shadows and Object Transparency. Let's look at how we can take these foundational rules of light we just talked about and actually use shadow density as a practical tool for environmental observation. We're going to step through a quick tutorial on identifying material types based purely on the shadows they cast. Remember this core principle: a shadow is always cast in the exact opposite direction from which the light hitting the body is reflected. So if light hits directly from the front, boom, the shadow falls directly behind. Okay, step 1. Observe if maximum light passes through a body. This makes it transparent, and crucially, it casts absolutely no shadow at all. Step 2. If the material allows only a portion of light through but reflects the rest, well, it's translucent, and it casts a faint shadow. Think of a frosted glass window or maybe a thin sheet of parchment paper. You can kind of see a shape but no sharp details. And finally, step 3. If the material allows minimal to no light through and reflects the maximum amount, it is opaque and it will cast a dark, highly defined shadow. A thick oak door or a heavy brick wall works exactly this way. You can actually use this as a practical guide to measure transparency with super simple shadow tests in the field. Look at the correlation here. It's a real game changer. A transparent object, like air, casts no shadow and is completely invisible to the eye. A translucent object, like that frosted glass we mentioned, has partial flow and partial reflection. This creates a faint shadow, making it only partially visible. But an opaque object, like our solid brick wall, reflects maximum light, casts a dark, heavy shadow, and is completely visible. Exactly how dark a shadow appears to you out in the field depends entirely on these exact phenomena of transparency and reflection working in tandem. So the absolutely crucial takeaway here is this: understanding whether light reflects off a surface or passes through an object directly alters your perception of its traits. Reflected rays reveal the external features. They show you the texture, the shape, the color. Penetrating rays, the ones that flow entirely through an object, reveal the internal features. Transparency dictates what's hidden inside, while reflection dictates what is shown outside. Mastering this duality, That is the key to true observation, trainees. Section 3. Bending waves and illusions. As you start mastering the basic observation of straight light rays, we've got to level up. We need to study the principle of bending waves to detect hidden environmental energy and understand how incredibly powerful illusions are formed. Notice how refraction acts as the core mechanism for manipulating spatial distance. When light flows from a less dense medium into a much denser medium, like, say, moving from open air into deep water, the compact nature of that denser medium's mass actually slows the light wave down. This resistance causes the entering light rays to shift their trajectory and bend. This precise bending of the light's path is what we call refraction, and let me tell you, it is a tremendously powerful tool in the physics of light. By bending these light waves, objects and environments can dramatically manipulate our perception. This bend fundamentally alters your perception of spatial distance, creating illusions that can make a destination appear much closer or significantly farther away than it truly is. But even more fascinating, refraction possesses the potential to render objects completely invisible. Seriously, because human sight is granted only when light waves reflect off an object and make direct contact with your eyes, if those reflected light waves are bent sharply away from your eyes, you entirely lose the capacity to perceive the object. It triggers a profound, partial blindness to that specific object, completely erasing it from your reality, even while it's standing right in front of you. To detect these hidden energies, we rely heavily on the wave's focus. The precision in a wave's focus directly correlates to your successful energy detection. A sharp wave focus grants sharp, highly clear sensory abilities, simply because there are fewer obstacles to scatter the information. But if there are obstacles, like imagine an inflow of cool air dispersing a concentrated heat wave, or a sudden new breeze diffusing the chemical waves of a previous scent, the wave focus becomes diffused. When this diffusion occurs, your sensory ability becomes blurred, scattered, and super unclear. Precision is absolutely everything when you're trying to perceive the unseen. Section 4. Balancing light and heat. We must now scale our perspective upwards, way upwards, to understand the fiery star principle. We're going to observe how light and heat actually balance planetary conditions on a macro level. Let's see how wave manipulation builds into these massive concepts. You can physically adjust a wave's focus through magnification. Convergence focuses waves to a single hyperspecific point. This is exactly how telescopes work, drastically reducing distance perception to pull faraway galaxies right into view. And because light sources like stars also emit intense heat, converging those light waves also concentrates the heat into a burning point. Divergence, on the other hand, does the exact opposite. It spreads waves out over a vast area. This increases distance perception, blurs the image, and crucially, disperses that intense heat over a much wider, safer zone. And this brilliantly illustrates how entire planets protect their habitable zones. The extreme heat from a star evaporates surface oceans, creating a thick atmosphere filled with massive amounts of vapor. When the stark white light of a star hits this atmospheric vapor, it diffracts into the 7 visible spectra, the brilliant colors of the rainbow. Now pay close attention to that word, diffracts. Unlike refraction, which just bends the light, diffraction actually splits and spreads the wave apart. As these countless droplets of water diffract the light, the beam loses its intense, burning focus. Because the light wave diverges and diffuses, the immense heat radiated by the star is dispersed safely. This diffraction of light and dispersal of heat is the exact mechanism that insulates a planet's surface, prevents it from burning to a crisp, and allows it to beautifully sustain life. Trainees, I need you to memorize this correlation regarding opacity, color, and heat resistance. While opaque objects don't let light pass through, their surface color determines exactly what happens to the heat energy. Brightly colored opaque objects reflect the light energy outward and simultaneously reflect the heat, making them highly heat resistant. This is precisely why builders in arid, scorching regions use bright white materials for their structures. Dark-colored opaque objects, however, reflect just enough light to show their dark color, but they absorb the incoming heat energy. They have dangerously low heat resistance. Left in intense heat, they will just continue to absorb that energy until their threshold is suddenly breached and they combust. Section 5. The mechanics of camouflage. Utilizing everything you've just learned about transparency, refraction, and reflection, we finally arrive at the tactical application of these optical physics, camouflage. A true master can conceal themselves from observers using 3 distinct methods of manipulating light behavior. First up, transparency, allowing maximum light to pass entirely through. As we discussed earlier, this completely masks the physical body and ensures it casts absolutely no shadow, leaving no trace whatsoever. Second, bending waves, placing a dense obstacle or medium that alters the path of light entirely away from the observer's eyes. The body is still physically there, but the observer only perceives the invisible bend. And third, a highly effective method using reflection known as contrast. So, the crucial point about this third method is that true invisibility isn't always about, just disappearing into thin air. If an object reflects the exact, precise wavelengths of light that its surrounding environment reflects, the visual contrast drops completely to zero. The physical presence absolutely remains. It places no refractive obstacles. But because it mimics the reflected light spectra of its background perfectly, the observer entirely loses the capacity to perceive it. It blends in flawlessly. It's a master hiding in plain sight. Section 6. Perceiving Hidden Conceptual Energy. For your final trial in this masterclass, we have to move beyond the physical world entirely and study the nature of immaterial light as a form of potential conceptual energy. To understand how humans align with this conceptual energy, I want you to picture something with me. Imagine two massive storage tanks, each 300 meters high. The first tank is a single open compartment. The second tank is divided into 3 separate compartments, completely sealed off from each other, but connected to the first tank by individual pipes at the 100-meter, 200-meter, and 300-meter marks. Now imagine water begins to slowly fill that first tank, drop by drop. This water represents the accumulated experiences and knowledge in a person's soul. As these life experiences continuously build up, the water level rises. When it finally hits 100 meters, it violently flows through the first pipe, representing a profound threshold of maturity, into the second tank. It must reach 200 meters to breach the next threshold, and finally 300 meters for complete, absolute alignment. That second tank, that represents immaterial light itself. You simply cannot perceive this hidden, conceptual energy until your accumulated experiences rise high enough to reach the specific thresholds of maturity required to connect with it. Okay, let's dive into this final vital rule. See, material light is fixed. A rock is a rock, a red brick is a red brick, right? But immaterial light represents subjective, abstract objects. And abstract objects do not have clearly defined universal physical traits. Their form alters depending entirely on the specific nature and maturity of the observer. Because it relies so heavily on the observer's internal state, multiple individuals will actually perceive the exact same immaterial energy in entirely different forms. The sensory ability you are granted to perceive these energies is determined by the precision of your focus and the deep reservoir of experiences you have accumulated. As our source text perfectly summarizes our masterclass today, the world you inhabit is a delicate, extraordinary balance. On one side, we have the linear, ordered physical light that reliably dictates shadows, shapes, colors, heat, and form. On the other side, we have a highly subjective, completely invisible spectrum of hidden conceptual energy that dynamically bends to the very nature and maturity of the person observing it. As your mentor, I leave you with this final, provocative thought. You now possess the knowledge of how transparent shadows work, how bent waves create illusions and disperse immense planetary heat, and how your own spiritual maturity unlocks the perception of immaterial light. So how will you use this explainer to see the unseen realities around you? Keep your focus sharp, trainees. Until next time.